What if the most terrifying objects in the universe were also the most misunderstood? Black holes aren't just cosmic vacuum cleaners. They twist time, distort space, and challenge the very laws of physics. But here's the real shocker. There's not just one kind of black hole. There are tiny ones, monster ones that might lead to other universes, and even ones that might not exist at all. In this video, we're traveling across the cosmos, from quantum-sized black holes smaller than atoms, to cosmic leviathans billions of times heavier than the sun. These are the 50 most mind-blowing black hole secrets and theories, and we're counting them down in order, from the smallest to the most massive. Our journey begins just moments after the Big Bang, an era so dense and energetic that reality itself was a roiling sea of quantum chaos. It's here that some physicists believe the first black holes may have formed, primordial black holes. These aren't like the ones we know today. They're tiny, smaller than atoms, yet packing the mass of a mountain. They could be scattered across the universe, invisible and undetectable, hiding in plain sight. Some believe these ancient relics might hold the key to one of the greatest mysteries in astrophysics. Black holes aren't entirely black. They slowly leak energy, shrinking until they vanish. It's the first clue that black holes might die. This process of evaporation is deeply tied to the world of quantum mechanics. In rare cases, particles might even quantum tunnel their way out of a black hole. This raises questions about the mysterious point at their center, the singularity, a place where density becomes infinite and physics breaks down. But what if that singularity doesn't exist at all? Loop quantum gravity offers a new model, replacing the singularity with a highly curved but finite core. Meanwhile, string theorists propose that black holes are actually fuzzy balls of tangled energy that smear out what we thought was a point of no return. Some even suggest black holes might never fully form. Instead, matter collapses just shy of the event horizon, frozen forever in time from an outside perspective. And in the world of wild alternatives, gravastars, strange stars made of exotic matter, could mimic black holes so perfectly we wouldn't be able to tell the difference. From the smallest, we leap to the more familiar. Stellar mass black holes, born from the death of massive stars. When a star at least 20 times the mass of our sun runs out of fuel, its core collapses, crushing atoms into oblivion and leaving behind a black hole. These objects are incredibly dense and powerful. Anything that gets too close is pulled into a fatal spiral, stretched by gravity into long threads, a horrific process called spaghettification. But it's not just matter that gets distorted. Time itself slows near a black hole. To a distant observer, time near the event horizon almost freezes. According to the no-hair theorem, these stellar remnants are frighteningly simple. They're defined only by three things: mass, spin, and charge. Surrounding many of them are accretion disks, glowing whirlpools of gas and dust heated to millions of degrees. We often detect them in X-ray binary systems, where black holes pull material from a nearby star. Some of these objects spin at incredible speeds, 99.9% the speed of light, creating intense distortions in spacetime. As light escapes their gravity, it gets stretched. Gravitational redshift dims it into the infrared. When two of these black holes collide, they release gravitational waves, ripples in spacetime itself. Detectors like LIGO have captured these waves, providing the first direct evidence of black hole mergers. But some black holes sit between the cracks, too large to be stellar, too small to be galactic giants. These are the intermediate mass black holes, a mysterious, barely glimpsed class thought to lurk in dense star clusters. Some scientists believe they may be the seeds from which galaxies grow, a hidden stage in the evolution from star to cosmos. And now we arrive at the true monsters, supermassive black holes. These are millions, even billions, of times heavier than our sun. Every large galaxy seems to have one at its core. The Milky Way's own is called Sagittarius A, a 4 million solar mass beast lurking 26,000 light-years away. In 2019, the Event Horizon Telescope gave us our first look at one, M87AX, a behemoth over 6 billion times the Sun's mass. Some of these giants power quasars, the brightest objects in the universe. Their radiation outshines entire galaxies, fed by black holes devouring gas, dust, and stars. Through their feedback loops, they influence star formation and even shape the galaxies they reside in. As they spin, some eject vast plasma jets, beams of matter stretching light-years into space. Surrounding them is a strange, ghostly region called the photon sphere, where light doesn't fall in, but orbits. From a distance, black holes can act as gravitational lenses, bending light from background stars and galaxies. But for all we've seen, the mysteries only deepen. What happens to information that falls into a black hole? According to quantum mechanics, information can't be destroyed. Yet in general relativity, anything that crosses the event horizon is lost forever. This is the black hole information paradox, a puzzle that's sparked decades of debate. And then there are the wild theories. Could black holes be wormholes, tunnels to other parts of the universe? The classic Einstein-Rosen bridge suggests so, but it might collapse too fast for anything to travel through. Some propose white holes, theoretical objects that spit matter out instead of sucking it in, miniature wormholes across space-time. Could this be the key to quantum gravity? Could black holes allow time travel? In theory, the extreme warping of space-time around a rotating black hole might permit time loops, though no one survived one to tell the tale. Even more provocatively, some theories suggest that every black hole contains a new universe, a cosmic reboot hidden behind the veil. And we're not done yet. Black holes, it turns out, have temperature and entropy, just like regular objects. They obey the rules of thermodynamics. Newer theories add even more intrigue, like quantum hair, which might encode subtle traces of what fell in. Others propose bouncing black holes, which avoid the singularity by rebounding like a cosmic trampoline. Some say that phantom energy, a strange form of dark energy, could shrink black holes instead of growing them. And finally, the wildest idea of all. What if the entire universe is a hologram projected from a cosmic to galactic titans? Just like a black hole are more than strange. They might be the very blueprint of the cosmos. Which theory blew your mind the most? Let us know in the comments. And if you're ready for more journeys into the unknown, hit like, subscribe for amazing space mysteries.